Yes, it's 3 now. We're going to start. Welcome everyone to our webinar on building an app-centric security program. Today our speaker is Avik Bose. Avik has been a systems engineer with F5 Networks for the past 3.5 years and is a SME for F5 security products for India. He has an overall industry experience of 14 plus years. His area of interest is dark web, SSL, hacking concepts, and more. We'll be taking questions at the end of the webinar. Kindly add your questions in the chat section. It's right at the bottom of your control panel. At the end of the webinar, Avik and I will be taking your questions. Avik, over to you.
Yeah, hi. Thanks for the introduction. And as mentioned before, my name is Avik. I have been a systems engineer with F5 for the past 3.5 years now, and I am a subject matter expert for the security products which F5 have for India. Now, before I start, I would like to know if my slide is visible to all, and if I am audible to everybody.
Yes, Avik, we can hear you and see your slides.
Okay, thank you. So this webinar is about building an app-centric security program and specifically focusing on API security. The reason behind this is that more and more organizations now are using API for a wide variety of purposes, and that's the reason it's important that the API infrastructure is secure. So with that, I will start my presentation. Q&A session, we will have 15 minutes at the end, wherein you can put your questions and I will try to answer them to the best of my capabilities. So the agenda will be as follows. I will start with a brief introduction on what API is. And then again, and then what API security is all about, and then how F5 can help you address these API security challenges, and then if time permits, a short section on the existing customers or wherein we have helped them with their API protection. So let's start with API overview. I'm sure that quite a few of you will be aware on what API overview is. So I will request you to please be patient and wait for the next section. So API stands for Application Programming Interface. And API expose something useful, which is an interface. So used by a program. So in a nutshell, what we are trying to explain is that API will be basically used by two programs to communicate with each other. And the interface, and the reason as to why we have used this example or an image of a power socket is because API will provide a standard interface through which two programs will be able to talk to each other. This just like if I have a shaver, and if I want to use that shaver, I will have to actually plug it into a socket, a power socket. This power socket actually gives me gives the shaver a standard interface through which it can draw power. Right? So similarly, an application programming interface gives a standardized interface through which two different programs will be able to talk to each other without any problems. Now, depending upon the API standard that you are using, again, the interface will be different. For example, if I go to US, the power socket will be different than a power socket than I get in UK or in India. So this is all what APIs are about. And again, this is very, very important, no direct human usage of APIs. APIs will exclusively be used, as I explained before, a program to interact with another program on another application. Developers write programs which consumes APIs. Now, this is again, we'll go into a little detail, try to explain the differences. So basically, when a client with a browser, let's say, tries to get this specific URL, http leewagon.org.program. So as soon as the client types in this URL in his browser, a GET request is generated by the browser, goes all the way to the server, and the server actually gives something to the client which can be rendered in the browser and would be presented to the client in a human readable format. So typically it will contain an HTML file, a CSS style sheet, a JS animation, a sheet, etc., etc. So yes, so as I was saying, the server will respond back to the client with a content which can be rendered by the browser and which will be in human readable format, which the client can actually see on his desktop, laptop, or mobile. However, if the same request, let's say the client has some kind of API tool installed in his browser, let's say Postman or REST API client, and if he or she makes the request to the same server using these API clients, what the server will respond back with will be raw data which can either be in JSON. If it's a REST API client, then definitely the response will be in JSON. It can be in CSV or it can be in XML format, which will be non-human readable, which only a program will be able to read and then take the corresponding actions based on that. And this is how, if you are, this is just an example, right? So if I am coding an API, or I'm sorry, if I am using some kind of API client, chances are very high that I will see the data that will come to me. So there are three different API types: internal, external, and partner. Internal, as the name itself suggests, that will be used within an organization or a company. So basically, prime examples of this can be that you have, let's say, a HRMS system wherein the employees will be able to see their leave balances, for which there is already a separate application that the organization has developed. So what the developers can do is, for their HRMS, they can develop an API that can actually connect or call that leave system so that the employees can see their leaves in real time. One of the many examples. External, these are, I think, most widely used. These are, and again, as the name suggests, these are primarily available to consumers. One of the most commonly used external APIs will be Google Maps. So we have a wide variety of food ordering applications these days, right? Zomato, Swiggy, etc., etc., right? And almost all of these applications have one thing is in common, is that when you are trying to put in your address, it will also try to auto detect your location as well, and that they typically do using Google Maps. So what happens in the background is that if you allow or if you give permission to their application to detect your location, it calls the Google Maps API so that it can actually go ahead and detect your location and then auto populate the address. And then partners, these will be specifically for B2B applications. So I am not very sure how applicable it will be for all organizations. This is basically, if you have a large ecosystem of partners, and then if you want and if you want to give APIs to your partners so that they can connect to you. Um, One of the use cases I can think of will be with banking industry, wherein, if specifically banks will have tie-up with certain retail websites, e-commerce websites, and so on, and in the event, right, if the bank wants that those retail websites or customers or e-commerce websites should again connect to the bank for certain specific scenarios. In that case, the banks can distribute these APIs to its retail or e-commerce partners. It's one of the examples I can think of. And Gartner, and this is the Gartner overview on APIs. Uh, just a footnote, it started with media and technology. Now APIs have moved into financial services, government, healthcare, and retail. And publishing APIs will continue to fuel the API economy, and the best is still to come. So again, exposing APIs, uh, what does it do for an organization? As this picture shows, it gives you or it can result in a tremendous amount of increase in traffic to your applications, which automatically will result in a lot more business coming in, which means more money, and more money means everybody in an organization is happy. So that is the whole purpose, or that is what the API economy we're talking about. Now, obviously, right, when you are exposing APIs, be it to your internal employees or be it to your external customers or be it to your partners, obviously the security perspective comes into picture, wherein definitely the API, the application that is consuming
बोल दो ना आपको, वो तो भी बाहर गया
these
हुआ है। बोल दो
uh,
अभी तो वो बाहर गया हुआ है।
the
और
information, and definitely the data in transit, that also needs to be secured. So definitely API security comes into picture.
बस मांग ही दे देना, मैं बात
And
कर लूँ।
this was again, this survey was done somewhere in 2016.
बोलना, लेकिन आप थोड़ा
And
रेजिस्ट ही करना, तो आपको कोई
again, specific to US, wherein it was, as you can see, the survey results, wherein 60% of the surveyed customers said that they have public facing APIs, 64% said that they have partner facing APIs,
ठीक है, चलो अभी मीटिंग में
and
हूँ और कुछ बात करेंगे।
and I think
हाँ, वो
34%,
आपके पास सुबह कॉल आई थी,
yeah,
तो बोल रही हो
32% said that they have internal APIs.
पता कि क्या
So
बोलना है, मैंने
again,
काफी
so as this slide shows, right? So most of the organizations, at least, they had uh, they were exposing either public, or they had public facing APIs or partner facing APIs, which basically means that public facing APIs basically means that it's accessible to the external world. So definitely that is something which will need to be secured. And 64 had partner facing APIs, which again meant that partners in security context, partners, I will say, they are semi trusted. So again, this is also something that will need to be secured primarily. And API security adoption rate. So, out of the organizations that were surveyed, only 30% said that if they had any kind of processes in place to check if the API consumer is handling the data uh, properly, uh, 60% said no, and 10% felt that it was not applicable to them. So when you come talk about API security, right? So there are primarily four pillars of API security, which starts with SSL, then identity enforcement, content validation, and then API security architecture. Now, we will go in brief about these four pillars in the next slides. So first is SSL. Now this is or strong SSL. This is very important because APIs, as I said, they provide an interface for two programs to each other, or for two programs to talk to each other. So it definitely means that these, through an API, two, a program and an application will be talking to each other, and they will be exchanging data. Now this data in transit, specifically when it comes to your external APIs and your partner APIs. So external APIs is basically means that uh, the application sitting in your data center will be talking to a program sitting somewhere outside on the internet, through internet, or basically through an insecure network, which basically means that you will definitely need to secure this data in transit by encrypting it to ensure that the payload doesn't get changed. Similarly, with for partners as well, because partners will be typically your suppliers, or as I said, or organizations that your organization will have some kind of tie up with. However, their network will not be in your control. So definitely, if a partner is trying to use the API given by your organization to connect to uh, an application server sitting in your data center, definitely that also needs to be. Therefore, the data in transit, needs to be secured to ensure that it doesn't get changed or it doesn't get modified, or malicious traffic is or malicious content is not inserted. So so definitely, whenever you are enabling SSL, which I'm pretty sure you will, for to secure the API data in transit, you have to or you have to keep in mind these 3 points. The check X509S, it basically means that you have to ensure that the proper root and the intermediate certificates, that entire chain has been properly configured. Be crypto selective basically means that you have to ensure that you are using the latest ciphers, the latest key exchange mechanisms. You are not using older version of SSL or TLS and so forth. And whenever possible, try to avoid the OpenSSL stack, because again, OpenSSL stack in the past few years has been hit by a wave of vulnerabilities, starting with Heartbleed. So, so that's the reason it's recommended that you avoid OpenSSL stack. Now, second is robust identity. This basically means that you will try to identify the end program that is trying to access, to use the API to access your or to use your application. Now, typically in these scenarios, what we recommend is that you use an industry standard authentication mechanism like OAuth or SAML to verify the authenticity of the programs that are trying to connect to your application through the API. And token integrity, and before selecting the mechanism or the protocol through which you will be going ahead and verifying the identity of the programs, you will need to ensure that you keep you take care of these 3 points. First is token integrity. Second is understanding token life cycle. This will help you determine as to which specific protocol or standard you should be using as the identity provider in your setup. And then definitely authentication is not enough. So this basically tries to say is that once you have, or while you are trying to select the authentication mechanism, you will also have to check, or you should also check and ensure that the authentication mechanism has some kind of content based access control in place or not. The third is valid API content. So APIs typically will have a request response structure wherein you send the request in one format and the response comes in another format. Now, typically what happens is that, like any other, the main application that will be consuming or that will be receiving the input from the programs and then sending the output back to the program typically will be a web-based application. And since it's a web-based application, it will definitely be vulnerable to the security threats a normal web-based application is vulnerable to, which will include OAuth's top 10 exploits, which will include data leakage, which will include credential stuffing or brute force, and which will also include uh, threat from scrappers, crawlers, spiders, basically all kind of bots. And the fourth and the most important point I will say is consistent security architecture. So basically, when you are trying to develop an API ecosystem for your organizations, you should ensure that the business processes are clearly defined so that business logic flaws cannot be exploited. Also, you should have a centralized platform, for rapid event auditing and policy management for your API infrastructure. Now, this was about API, what APIs are, and what are the four pillars of API security. Now, I'll give a brief introduction about what F5 is and what we do. So, F5 was founded in the 90s. We have it. It is listed in Nasdaq. The IPO of F5 came in 1999. The fiscal revenue for this year is a little over 2 billion US dollars, and our employee strength has increased to 4,500 employees worldwide. Now, F5 traditionally has been known as a server load balancing company because of the fact that we were the ones who coined the term ADC along with Gartner, and we have been in the Gartner's Leaders Quadrant for the past 10 years in a row. The last report came in 2016. So after that, no report has come in. So you can see a snapshot of the 2016 Gartner's report. Now, apart from server load balancing, we do a lot of security as well, or we have a lot of security products as well. And as you can see, that we were positioned as a leader in the Gartner's Magic Quadrant for web application firewalls in 2017. So we have a very good security story in place as well. Now, F5 API protection, as to how we will help you protect, or how F5 security solutions will help you secure your API infrastructure. So basically, in a nutshell, there are three basic parameters what we think of API security. The first is visibility, the second is context, the third is control. Visibility means that you will need to have visibility into the threats that are coming into your API infrastructure. Then you need to have context as to, or basically correlate, these threats in relation to your API infrastructure. And then once you have these two pieces of information, then definitely you will get down to the business of actually going ahead and controlling those threats. So visibility. So with F5, right, what we say is that visibility should extend right from the network all the way up to the app layer where your API infrastructure will reside, right? So we should have visibility into the threats that are coming into the network, then DNS, then SSL, then the access layer, and then all up to the app layer. And as you can see, once you have visibility, you will be able to see the kind of threats or the kind of attacks each specific layer is subjected to. This is visibility into the cloud if your API infrastructure is available, is deployed on the cloud. So traditional security solutions only give you limited visibility, while typically F5 security solutions are targeted towards, as explained before, giving visibility into this entire stack. One minute, I'm just trying to readjust this. And then once you have visibility, right, then you need to put it into context, which basically means that you will need to understand that what an application normal behavior is, so that you can recognize, or it will have a better understanding in pinpointing abnormal conditions wherein your application is not behaving as expected. And there will be various parameters wherein you can try to put a context to. uh, some of the examples we have given here: browser, operating system, device and type integrity, authentication. uh, an example for a browser will be that if your application is normally accessed by, let's say, Chrome or Mozilla, and if all of a sudden you see that a lot of requests are coming from IE or Edge now, to which your application is not able to behave properly because it has primarily been designed to, serve request out of Mozilla or Chrome. Then that's an abnormal situation. Or let's say, for example, in context of APIs, now that your application has primarily been designed to receive API requests from a lot of third-party partners which you have. Now, all of a sudden, if your security solution starts showing you that you are getting a lot of requests from normal browsers, or at least user agents which claim that they are browsers, obviously because of which your application is not able to process those requests properly and throwing a lot of internal errors, then that basically means that that's an abnormal condition. There are other examples as well, which I will not go into detail because of uh, uh, time constraints. And then control. So once you have visibility, once you have control, once you have context, then you can decide, as to what kind of security controls you need to put in place to protect your API infrastructure. So this is the entire slide, end to end. You have app on one end, you have which is sending the data, which you have app on the other end, which is consuming the data, and then you have these four pillars of API security. So strong TLS, how do you address it? By being a full SSL proxy, which basically means that you can pretty much fine tune or change any SSL parameter that you need to secure your API, to secure the data in transit. Then robust identity. This basically means that, again, with F5 solutions, you have an option to select the best authentication mechanism, or to put it in a better way, the F5 solution can act as an identity gateway wherein you can, without making any kind of changes to your application, you can select the authentication mechanism for your API infrastructure, be it OAuth, be it SAML, or be it LDAP-based authentication. And the third point was the valid API content, wherein with F5 solutions, you will be actually able to inspect the data that is coming in uh, through the API to your applications, and then inspect them at the application layer level to protect them from bots, from credential stuffing, etc., etc. Now, this again, we were going into detail as to how we will be how strong SSL or how F5 solutions help you implement strong SSL. We do it because, as I said before, we are a full proxy for HTTPS, which basically means that you will be able to select the protocol, the cipher, the key exchange mechanisms, and so forth when you are implementing the SSL, uh, the SSL infrastructure for your API. Definitely, since we have dedicated SSL cards to actually process the SSL traffic, so therefore, we will be able to process very high volume of SSL transactions per second, while at the same time ensuring that that you have the best of SSL stack implemented in place. Robust identity, as I said before, that we can act as an authentication gateway wherein we, without making any kind of changes to your API infrastructure, we will take the request from the partners or the external customers that you may have, and we will ensure that depending upon as to what kind of authentication mechanism you want to implement, whether it's OAuth or whether it's SAML or whether it's, as I said, LDAP-based authentication, we will authenticate the API clients on your behalf and then pass the request onto your application service. Valid API content. This will typically be, or this will typically be your application layer protection, wherein which we will ensure by inspecting each request that goes to your application through the APIs and each response that comes back. And we can do it because we are a full HTTP proxy. We have a JSON parser built into our HTTP proxy, which because if you are, we have included JSON because uh, typically JSON is used by REST API clients, and it's one of the most widely used, APIs worldwide. So having a JSON parser built in basically means that we will be able to uh, validate each JSON request and response and drop or allow certain JSON parameters as defined in the policy. We have the world's best anti-bot protection mechanism. We have an integrated XML firewall. In the event your API client and the application exchange data in XML, we will automatically protect against OAuth's top 10, and we have a brute force login protection also built in, including credential stuffing. Now, these are some of the success stories which we have already implemented for our customers in US and UK. The first, it was a large US financial customer. Again, their main challenge was that they were seeing that distributed random credential stuffing, uh, and they were using the OFX protocol. And since it was APIs, right? So definitely no JavaScript challenge could be used to detect bots, as well as device fingerprinting couldn't be used. F5 solution. Give me a minute. Choose the position of this. We started with iRules, which is our proprietary scripting language, wherein the criteria was that after 3 failed authentication attempts, block the IP, which led to 20% mitigation. Then we added on our IP intelligence on top of our solution. IP intelligence is nothing but our bad IP reputation database or our IP reputation database, which added to 50% mitigation. And finally, on top of it, what we added was, since we couldn't go ahead and do a device fingerprinting, what we started doing was a SSL based or a TLS fingerprinting, which we incorporated in our iRule, which led to 100% mitigation or 100% mitigation of the attacks that the customer was seeing on their API infrastructure. The code can be found here in the GitHub link. The second was a top mobile collaboration app provider or a VAS provider. The challenge was that bot activity and layer 7 DDoS on their API infrastructure. So the solution was to rate limit using again an iRule to rate limit and block the offensive traffic and distinguish based on JSON parameter. As I said, we have an inbuilt JSON parser, so which gave us that flexibility. This was an utility provider using Internet of Things. their challenge was that they wanted to protect the WebSocket JSON structures from OAuth's top 10 attack. So this, we actually went ahead and implemented our web application firewall, which helped them, mitigate these attacks. So that's the end of this slide. Now we are open for Q&A.